Concavity algebraically. Since we were able to graphically interpret concavity, now we will discover how to algebraically determine concavity and points of inflection. Derivatives can tell us a lot of information about the original function. When evaluating the first derivative, its sign told us whether the function was increasing or decreasing. Remember how we made the sign chart for it and tested points? That's what this sentence is referring to. Next, we're going to discover how the sign of the second derivative determines whether the function is concave up or concave down. The first step in finding intervals of concavity algebraically is to find critical values for the second derivative. These critical values will occur when the second derivative is equal to 0 or is undefined, similar to the critical values in the first derivative. Whenever they were 0 or undefined, that's what we had. So this time we're dealing with the second derivative. The sign of the second derivative determines the concavity of the original function. If f double prime of x is positive on an interval, then f of x is concave up on that interval. If f double prime of x is negative on an interval, then f of x is concave down on that interval. If f double prime of x has a critical value at x equals c and changes signs from before to after, then x equals c is a point of inflection, provided the function is defined at x equals c. So remember when we were talking about concavity with graph analysis, we had a concave up. You could think of a cup or a smiley face. It looks like this. And it's positive when it shows this cup or smiley face. So you could think of it as smiley face is positive, and then the frown meant concave down, and that's when it is negative. So just a few clever ways to remember which sign yields the shape of the graph.